Okay. So, good afternoon, everyone. Welcome you all for NTA lecture. So, in the previous lecture, we have started the unit number 4, that is the transient response. So, in the previous lecture, we have completed the introduction part. So, in the introduction part, we have covered the definition of steady state response. Then we have covered the definition of or concept of transient state. Then we have seen the transient time, what we mean by transient time. Then we have seen the concept of the mathematics 3, which is required, that is the linear differential equation and Laplace transform we require to analyze the transient response and steady state response. So first of all, we are using the linear differential equation here. So steady state analysis or steady state response is represented by particular integral, and transient response is represented by complementary function. So these two parts are nothing but solution of linear differential equation. Are you getting my point? So we are finding out the steady state and transient response of RL circuit, RC circuit, and RLC circuit in this chapter. Okay, but for that purpose, we are giving what the step voltage or step current, or indirectly we can say that DC sources we are going to connect. It may be voltage source or it may be current source. So when we are connecting the DC sources, we are going to find out the transient response and steady state response with respect to RL circuit, RC circuit, and RLC circuit by using what linear differential equation as well as Laplace transform. So after this, we have started the DC response or step voltage response of RL circuit. So here RL circuit is there. RL both are in series here, resistor and inductor. And consider a RL circuit shown in the figure given below. So the switch, what is the importance of switch or what is the role of the switch? I already told in the previous lecture. So here the switch is named as S. So that switch will close at time t equal to 0. जेव्हा तो switch close होईल, then and then the circuit will become closed loop and the current will circulate. If switch is open, then current will not circulate. It becomes open circuit. Okay, but as inductor is there, it will oppose the flow of variable current. जेव्हा constant current होईल तेव्हाच तो voltage drop देणार. Okay, so here voltage source V is connected, that is the type DC, we can say the step voltage. So when it is connected, when the switch will connect to this point at time t equal to 0, as soon as the voltage is connected through the switch, the current I will be circulated. So we are finding out now current equation. So current will give the current equation, whatever we are getting in that, two parts will be there. One is the complementary function and another is the particular integral. So particular integral will give steady state response and complementary function will give what? The transient response. Okay, so initially before closing the switch, yes, at time t equal to 0, the current in the circuit is 0 ampere because it is open circuit, and assume that there is no charge on inductor initially. Okay, that's why the current, when the time is less than 0, the current in the circuit is 0 ampere. That is I have written. So this is the way of writing before the switch closing, that is the t is equal to 0 minus, म्हणजे exact 0 नाही किंवा 0 plus नाही. When the switch was not closed, before that the time is written as t is equal to 0 minus. Next, when the switch S will close at time t equal to 0, then current I will be circulated in the circuit in a positive or in a clockwise direction. Clockwise, how I will decide clockwise? Because according to the polarity. Polarity baga, plus is there and minus is here. So according to this polarity, the current will circulate in the clockwise manner. Now next, I am going to apply the KVL here in this loop. So according to the direction of I will mark the polarity of voltage drop across resistor R and across inductor L. So plus minus I have marked. So now I will be ready for applying the KVL. So KVL rules, you know that left hand side bottom point you can select as a starting point as well as the end point. Go in a clockwise direction. If you are observing minus first, you can write the positive value. If you're observing first plus, then you can write negative end. So minus to plus, that is a plus V. Next come to here, plus to minus is there, that's why minus. Next, how to find out voltage drop across resistor? That is R into this I. Next, plus to minus is there, that's why minus. So how to find out voltage across? L into by dt is equal to 0 here. Now, I have just taken here L into di by dt plus R into I is equal to V. Okay, so divide both side by L. Divide both side by L. Why I am doing this? Anyone can tell? I already told the reason why I am doing divide both side by L. Anyone?
Because coefficient there should be 1.
Yes, very good. So for higher order term, higher order means what? Derivative higher order. Here it is only first order. Okay. So for higher order derivative term, the coefficient must be 1. Okay. So for that here L is mentioned. So if I am dividing both side by L, then automatically it becomes 1. So divide both side by L, I am getting di by dt plus R by L into I is equal to V by L. So this is I have given as a equation number 1. So if you are comparing this equation with a non-homogeneous linear differential equation, okay. So that equation, standard equation I have given, dx by dt is equal to px is equal to k, where k is the constant, x is the variable, x is replaced by I here, p is replaced by R by L, and k is replaced by okay, V by L. So solution is what? Solution what of this equation? Solution is what? That is given here. So we are finding out the x. X is equal to e raised to minus pt integration of k into e raised to pt into dt with respect to t plus c into e raised to minus pt. आता या दोन्ही टर्म मध्ये सीएफ कुठला आहे आणि पीआय कुठला आहे? Who will tell? Which is CF and which is PI? Yes, anyone? Hello, my question, are you understanding everyone? In this solution, which is the PI and which is the CF?
C into e raised to minus pt CF.
Yes, integration is there, no? From integration, you can easily tell, no? So this is what integral, particular integral. So this will give the steady state value. This will give the steady state value, where C into e raised to minus pt. This is what? Transient response. This is what? Transient response. This is called as complementary function. So what is C here? Anyone can tell what is C? C means what? C is nothing but arbitrary constant. C is what? Arbitrary constant that you have to find out. There's a value किती असते ते तुम्हाला find out करायचे. So that value of arbitrary constant C, you have to find out by using initial condition as well as final condition. That you have to find out by using initial condition as well as final condition. Okay. So next, up to this point, we have discussed in the previous lecture. So take a 30-second, everyone. Read it each and every point in this given slide. And then I will start the new point. Or new point means next point after this. I will start. Take a 30-second, everyone. If you are understanding this, then to solve the numerical exam becomes very simple. Okay. I hope the screen is visible now. So we can continue the next point here. So the equation, that is the, I will write once again here. So dx by dt is equal to what? Px is equal to k. Okay. So this is what equation 2 I will give. So whose solution is x is equal to e raised to minus pt integration of k into e raised to plus pt with respect to t plus c into e raised to minus pt. So this is what equation number 3. So if you are comparing this with equation number 1, so equation number 1, what we got? Anyone? Equation 1 क्या आया था? di by dt plus r by l into I is equal to v by l. So that also I will write di by dt plus r by l into I is equal to v by l. So this is my equation number 1. So all three equations I will write. Okay. Now next, here if you're comparing with equation 1 and equation 2, so what are the values of I, then k, then p? Here x is replaced by what? I. Then p is replaced by what? R by l. And k is replaced by what? P by l. So put these values in equation 2. Put these values in equation 2 to get solution for equation 1. To get solution for equation 1 LDE. Equation 1 काय आहे? LDE आहे ना. So त्याचं solution काय आहे? आता आपण काढणार आहे. By replacing x is replaced by I, then p is replaced by r by l, and k is replaced by v by l. So that we have to put in equation number 3 म्हणायचं. Sorry, equation 3. So put these values in equation number 3 to get the solution for equation number 1. So I will write here x is replaced by I, then e raised to minus pt. So minus pt, p means what? R by l, minus r by l into t, e raised to minus r by l into t. Then integration of k is replaced by v by l into integration of r by l into t. Next, with respect to t, plus c into e raised to minus pt, that is minus r by l into t. Okay. So you have to solve now integration. You have to solve this integration. So this v by l is a constant. I will take outside v by l as it is outside. You can take e raised to minus r by l into t as it is. So what is the integration of e raised to r by l into t with respect to time t? Anyone can tell? So next further point will be as it is. You have to keep. So what is the integration of this term? What is the integration? Exponential term. V by L as it is. E raised to minus R by L into T. I will keep as it is. What is the integration of this term with respect to time t?
E raised to R by L T upon T.
R by L into T as it is. Divided by काय? Multiply by.
Divided by.
Divided by?
T.
Not T.
R by L.
R by L येणार ना? Divided by R by L. R by L will come. Okay. कारण हे इथं A into T आहे. So e raised to at चं function काय येणार? Integration e raised to at with respect to t. What is the integration?
E raised to a upon e.
E raised to at divided by a na. A means what? R by L. So that you have to write. Okay. Now the next point will be plus this plus c into e raised to minus r by L into t as it is. Now, any cancellation? Anything we can cancel here from this side?
L.
High L and high L cancel होतो ना? Both L will get cancelled and V by R becomes V by R. Okay. Next, e raised to minus R by L into T into e raised to plus R by L into T. Hence, काय येईल answer?
1.
V by R as it is. E raised to 0 येणार ना? E raised to 0. So e raised to 0 I will write plus C into e raised to minus R by L into T. So this is what I. Now what is e raised to 0?
1.
E raised to 0 is 1. So I is equal to V by R plus C into e raised to minus R by L into T. So this is my expression here. This is my expression. So which is the complementary function, which is the particular integral? I will tell which is the transient response and which is the steady state response. So this I will give the equation 4 here. Who will tell now which is the steady state response and which is transient response?
V by R is steady state.
V by R is steady state. Very good. Because steady state response will be constant. V by R कधी होणार जेव्हा स्विच खूप वेळ क्लोज राहणार. Okay. So voltage divided by resistor will give constant current. So that is called as steady state. With respect to this time t, it is varying. So that's why it is called as what? Transient state response. Steady state response and transient state response. So equation 4 is the final answer or what? Or still we have to find anything? Still we have to find anything, or this is the final equation for this derivation? Who will tell?
We need to find C, na?
Yes, very good. So we have to find out the arbitrary constant C. We have to find out arbitrary constant C here. So for that purpose, we have to use the initial condition, final condition. So here we have to use initial condition. Initial condition oblique final condition we require either of one. Okay. So initial condition is why it is used to find out the arbitrary constant. To find out value of arbitrary constant C. Arbitrary constant C. So how to find out this arbitrary constant? By using initial condition. So what is the initial condition? Who will tell?
T equal
What
to
is the
0.
state? Yes. Okay. So initial condition T is equal to 0 minus 0 minus. Don't take exactly 0. Okay. So T is equal to 0 minus means before closing the switch. So before closing the switch, before closing switch at T is equal to 0, the current in the circuit, what is that?
0.
0 ampere.
The current in the circuit is 0 ampere. Current in the circuit is 0 ampere. That is, now you can take T is equal to 0 minus E is equal to 0. Mathematically 0 minus you cannot put. Instead of that you can put 0. And I is replaced by 0. 0 ampere. So T is equal to 0 you can put and I is equal to 0. कारण जरी स्विच क्लोज झाला तरी इंडक्टर लगेच करंट चेंज करू शकत नाही. इंडक्टर अपोज विल चेंज इन द करंट. इंडक्टर सडनली अपोज द चेंज इन करंट. इनिशियली 0 एम्पियर पण जेव्हा तुम्ही स्विच क्लोज करता तेव्हा ऍक्च्युअली काहीतरी करंट फ्लो व्हायला पाहिजे. पण थोड्या वेळासाठी थोड्या सेकंदासाठी तो इंडक्टर काय करतो प्रिव्हियस करंटच अज्युम करतो. इट विल ट्राय टू अपोज. सो त्या पिरियड मध्येच आपल्याला ट्रान्झिएंट स्टेट काढायचं. Okay, so for that purpose, you can, even though the switch is closed, the current for some time remains zero only. Okay, even the switch is closed, for some time the current in the circuit remains zero only. That's why we can take as it is here. T is equal to 0 minus is nothing but 0 plus, and I is replaced by 0 ampere. So these two values you have to put in equation number 4. Put these in equation number 4. Put these in equation number 4. So we get, what you can get, I is replaced by 0, V by R as it is, plus C into e raised to minus R by L into T is replaced by what? 0. So e raised to 0 means what?
1.
1. Okay. So V by R is equal to C into 1 means C. So what is value of C now? 0 is equal to V by R plus C. So what is the value of C?
minus V by R.
Yes. So C value is minus V by R. C is nothing but minus V by R. Okay. So we got now the value of arbitrary constant C using initial condition. So this value you have to put again in equation number 4, so that you can get equation number 5, which is the final expression for step voltage response of or DC response of RL circuit. So we can put now the C value equation number 4. So everyone understood? Can you read? Can take 30 seconds. Read each and every step. If any questions will be there at any point, you can ask. We have to complete this theoretical part, and after that we have to solve numerical example based on the DC response of RL circuit. So after completion of each and every theoretical point, according to the type of circuit, we can immediately solve the numerical examples. If any questions will be there, you can ask at any stage. Any questions?
No, sir.
Okay. What about others? 126, 124 students are there. Now, we can put this value, we can put this value in equation 4. Put this value in equation 4, we get. So this will be the final expression of the current I. So I is equal to V by R minus C is replaced by V by R. C is replaced by minus V by R into e raised to minus R by L into T. Am I correct?
Yes.
This is what equation number 5. Or you can further simplify, or manto I is equal to V by R, you can take common. In bracket, what is remaining? 1 minus e raised to minus R by L into T. So this is also acceptable. Combine the equation number 5. Okay, so V by R is steady state response, and the transient response is what? V by minus V by R into e raised to minus R by L into T. That is the transient response. Suppose I want to draw the diagram of current I versus time constant τ. Time constant τ. Okay. So what is the τ? τ is nothing but time constant for RL circuit. Okay. So again, we can discuss the new points here. So I will draw the transient response here for RL circuit. Transient response. Transient response means only this part we can consider. This is TR, transient response. Okay, so transient response for RL circuit we can discuss now with the help of equation number 5. Suppose I am drawing now transient response with the help of graph. So this is the x-axis, time constant. Time constant is tau, not t. It is the tau, time constant. On y-axis, I will take current I. So it will start from 0, time constant 1, time constant 2, time constant 3, time constant 4, time constant 5, up to infinite like this. So what is the maximum value of current? Anyone can tell? Maximum value काय असू शकते? Suppose at t is equal to 0, what is the maximum value?
0.
T is equal to 0.
0.
Okay, the maximum value. Only think about transient response. Huh? I'm not telling about the I value, total I. Okay, so it will become what? 0. It will start from 0. So as time constant is going on increasing, the response is also going to increase, and finally it becomes what? V by R. म्हणजे जेव्हा तुम्ही infinite ठेवाल, time t is equal to some point you are keeping, at that time it will become V by R. So that is the final value. So somewhere, so that we can get at tau is equal to 5. So हे कसं आलं मी तुम्हाला सांगतो. So this is what V by R. This value is nothing but V by R. Okay, so this is what steady state response. V by R ला आलं की steady state. जेव्हा तुम्ही स्विच क्लोज करता तेव्हा काय असणार आहे? ऑलरेडी बिफोर क्लोजिंग द स्विच इट इज इन ऑलरेडी स्टेडी स्टेट. मग करंट त्यावेळेस किती होता? 0. पण जेव्हा तुम्ही स्विच क्लोज करता तो ट्रान्झिएंट टाइम पास झाल्यानंतर तो परत स्टेडी स्टेट मध्ये जातो. मग स्टेडी स्टेट मध्ये V by R कॉन्स्टंट राहतो. ओके, मग V by R कॉन्स्टंट म्हणजेच करंट कॉन्स्टंट. मग एका स्टेडी स्टेट पासून दुसऱ्या स्टेडी स्टेट मध्ये जे कन्वर्ट व्हायला टाइम लागेल ना, दॅट टाइम इज नथिंग बट ट्रान्झिएंट टाइम. मग त्याच्यातनं जे रिस्पॉन्स येणार आहे त्याला ट्रान्झिएंट रिस्पॉन्स. Are you understanding the concept, everyone? So two steady states were there before closing the switch and after closing the switch. So before closing the switch, the transient state, the steady state value is 0, that is current value is 0. And after the closing the switch for some time, it will again come in a steady state and it will give the constant current that is given by V by R. So between these two steady state, what is the phase is there? That is nothing but transient state, and we are finding out that transient response here. So time constant tau. So time constant tau is depends on L by R value. Time constant is denoted as tau is equal to L by R. So it depends on what? L by R. So if L by R I am keeping, time constant unit काय असते? It is the second. Time constant unit second मध्ये. So if I am replaced by L by R by tau, so what will be my equation? I is equal to V by R into 1 minus e raised to minus t divided by 2. This is my equation number 6. You can take, but transient response is only, we are not including here. Transient response and steady state response is V by R. Transient response is V by R into e raised to minus t divided by 2. Okay, so we are at what? Why we have taken at 5? 5 लाच का steady state येतो? Anyone can tell? What is the reason behind this? Steady state value काय? Final steady state value, steady state final value, किंवा steady state second value, what will be? It will be V by R. Okay, आपल्याला 0 पासून V by R रीच करायचंय. मग कुठल्या टाइम कॉन्स्टंट होणार ते? 5 I am drawing here in the graph. So can we prove this? आपण प्रूव्ह करू शकतो का? Can we prove this? Yes, can we prove this? See, so at t is equal to 1 to पहिला t ला 1 to गया, this is 1 to 2 to 3 to 4 to 5 to. At 5 to it is reaching the steady state value. So this is called as what? Steady state value. Steady state value V by R. या स्टेजला गेले की तुम्हाला काय मिळणार V by R. So at t is equal to 1 to, if you are putting in this transient response म्हणजे इथं मायनस करूया आपण. So what will be the answer here? I is equal to minus V by R into e raised to minus t is replaced by 1 to divided by 2 as it is. So 2 will get cancelled. So what is the e raised to minus 1? E raised to minus 1 से किती आहे answer? Take a calculator and tell what is e raised to minus 1 value.
0.3678.
Yes, 0.367 किंवा 368 into V by R naught. E raised to minus 1 म्हणजे 0.368 and minus V by R as it is here. Now next, put at t is equal to 2 to. So I is replaced by what? Minus V by R into e raised to minus 2 into 2 divided by 2. So 2 will get cancelled. So what is e raised to minus 2?
0.1353.
0.15,
135.
0.1
353.
35, okay, into V by R. Now I will directly move towards the fifth point, dash dash dash, you can do it. At t is equal to 5 to, what is the answer? I is equal to minus V by R into e raised to minus 5 to divided by 2. What is this answer now? Minus 2 will get cancelled.
0.0067.
0.006, okay, into V by R. So can we tell now 0.0006 means nearly 0? Yes? Yes or no? Okay. So means at 5 to, if you are putting the 0 value here in the equation number 6, so transient state becomes totally 0. So only what is remaining? Steady state. What is remaining?
Steady state.
Only steady state. At 5 to, the transient state will over. At 5 to, the transient state over, and only remains what? Steady state. Means the circuit will become again in a steady state after 5 to. So that is the final remark I will write. At or after time constant 5 to, after time constant 5 to, the RL circuit becomes in a steady state. That will give the constant answer I is equal to V by R. So this is very important. So from this, the 2 to 3 MCQ will get formed. One is the equation. Another is what? After what time the steady state will become in RL circuit. That answer is the 5 to. So tau means what? Time constant. Tau is defined by L by R. L आणि R जर दिला असेल सर्किट मध्ये तर तुम्ही ते व्हॅल्यू टाकून टाइम कॉन्स्टंट काढू शकता. So into 5 if you are doing, you can get the time period. So after time constant 5 to, the circuit becomes in a steady state. मग क्वेश्चन असं विचारलं जातं, एक RL सर्किट दिलं जातं and they will ask after which time the circuit will become in a steady state. So you have to first of all find out tau. So once you get the tau value, then you can multiply by 5. So that will give the total time period for duration in which the transient state is there. म्हणजे किती वेळापर्यंत ट्रान्झिट स्टेट होता तो ड्युरेशन तुम्हाला कॅल्क्युलेट करता येईल. So this is about what the DC response of RL circuit. So we have just taken here voltage source. Okay, voltage source have more value compared to current source because voltage source connect केले की current automatically flow होणारच आहे. Are you getting my point? So we can solve now one numerical example, one or two, so that we can understand, because most of the times based on this unit, most of the questions are based on numericals only, or they can ask the derivation like explain the DC response or step voltage response for RL, for RC, they can ask. So once again, you can read within a few seconds. If any questions will be there, you can ask. Otherwise, we can start to solve the numerical example. Okay. So we can start to solve the numerical example now. Numerical examples on DC response of RL circuit. So first of all, you can read the question here as well as observe the diagram. So consider the circuit. Consider the circuit shown in figure. Determine the current I. Determine the current I. Oblique, comma. Voltage across resistor R and voltage across inductor L. Voltage across inductor L. When switch S is closed, switch S is closed at time t equal to 0. So this is what the question, and you can observe the diagram also. Okay, so resistor value is 30 ohm, inductor value is 15 Henry, and this voltage source is 60 volt, and the switch is closing at time t equal to 0. And you have to find out the current I when the switch will close at time t equal to 0. That current will shown here I. as well as you have to find out voltage across resistor R, voltage across inductor L. But condition is what? When switch is closed. After that, you have to find out all these responses. So how to start to solve this example now? So first I will explain all those things. While solving the second problem, you can tell. Okay. So we can start here to solve this example solution. So when switch S is closed, when switch S is closed at time t equal to 0, then by using KVL, we can write equation. जेव्हा switch close होईल at time t equal to 0, then current I will be circulated. Then by KVL, we can get current I. We can get the current I. So you can apply now. This is plus here, this is minus, this is plus here, or we can draw the circuit once again. Don't make any changes in the question itself. This is plus minus 60 volt. This is what 30 ohm. This is what 15H. This is plus minus. Switch is closed at t equal to 0. You can mark the current value, current direction I. So by applying the KVL, what is the equation now? Start from this point, go in a clockwise direction. Minus to plus. Minus to plus काय येणार? Minus to plus 16 है ना?
Yes.
Next come to here. Plus to minus is there, that's why minus. So resistor value into current, that is the voltage, 30 into I. Next come to here, plus to minus, that's why minus. But L into di by dt. So L value is 15 Henry. L into di by dt, L value is 15 into di by dt. जर तुम्हाला डायरेक्ट व्हॅल्यू कळत नसेल तर तुम्ही इक्वेशन लिहा. 60 minus R into I minus L into d by dt is equal to 0. Like this you can write and then put the value of resistor and inductor. एक step वाढेल फक्त. Now take a negative part common, then it will become 50 into di by dt plus 30 into I is equal to 60. So what I have to do now? I want higher coefficient, higher degree. Coefficient should be 1. So what I will do here?
Divide by 15.
Yes, divide both side by 15. Divide both side by 15 here. Because for higher order coefficient, higher order differential equation term, I need the coefficient 1. So it will become di by dt plus 30 by 15 means 2 into I is equal to 60 by 15 means 4. So this is my first equation. So this is what? This is non-homogeneous linear differential equation. Linear differential equation. Okay, where P is equal to 2 and K is equal to 4 and X is equal to I. So whose solution is म्हणजे equation number 1 चं solution मी directly लिहितो. So that will be solution काय येणार आहे? I is equal to e raised to minus pt integration of k into e raised to plus pt with respect to t plus c into e raised to minus pt. So you can put all those values p, k and x. Okay, x मी तर इथं पण x लिहू शकता किंवा डायरेक्टली I म्हणून लिहू शकता, काय अडचण नाही. So this is what the first page. Now we can move towards the next point. काय कळालं? So when the switch is closed at time equal to 0, the current I will be circulated, and that we can find out by applying the KVL here. So KVL we applied in a clockwise direction, and I got the equation number 1. So this is what non-homogeneous equation, linear differential equation. So for that, I want to find out the solution, which consisting of particular integral as well as complementary function. So that I will find out by putting P is equal to 2, K is equal to 4, and X is replaced by I. So I already taken. So P and K value you can put and get the equation. After that, you can find out the arbitrary constant here. So we can move towards the next point. Now here I will write I is equal to e raised to minus pt. P is replaced by what? 2, e raised to minus 2t. Integration of k is equal to 4 into e raised to plus 2t with respect to t, plus c as it is e raised to minus 2t. So this is I will put after the value of p and k. Now solve this integration. If you are solving this integration, what you are getting? I is equal to, so e raised to minus 2t, integration of 4 you can take outside, e raised to minus 2t and e raised to 2t, that will give 0. So integration you know, किंवा अजून एकदा आपण इंटिग्रेशन काढूया, काय अडचण नाही. e raised to minus 2t, this as it is. Integration of e raised to 2t is e raised to 2t divided by 2 nr. Next plus c into e raised to minus 2t as it is. So this 2 and 4 you can cancelling here, 2 will become e raised to minus 2t into e raised to 2t is e raised to 0. So e raised to 0 will give 1. So I is replaced by 2 plus c into e raised to minus 2t. So this is my equation number 2. This is equation number 2. Now how to find out the value of c? So that for that purpose you have to use the initial conditions. You have to use the initial condition. So what is the initial condition? What will be the statement here? How to write the initial condition? Anyone?
Before the closing switch t equal to 0, then current in the circuit is 0 ampere.
Yes, very good.
That is t equal to 0.
Yes. So before closing switch, at t equal to 0, current in the circuit is 0. Current in the circuit is 0 ampere. So even though switch is closed, this statement is very important. Even though switch is closed, even the switch is closed, inductor does not allow sudden change in current. जो previous होता तोच तो थोड्या वेळापर्यंत घेणार. Inductor does not allow sudden change in current. That is, I will write here, that is for t is equal to 0 plus also the current in the circuit remains 0 plus. Switch जरी close झाला तरी काही वेळापुरता 0 plus current in the circuit remains 0. Therefore put t is equal to 0 and I is equal to 0 in equation number 2. In equation number 2 you can put these values. So I is equal to 2 plus c into e raised to minus 2 into 0, and I is replaced by what? I is replaced by 0. Okay, so 2 plus c into e raised to minus 2 into 0. So e raised to minus 2 into 0 means it is 1. So 2 plus c is equal to 0. So what is my answer of c? It is what? Minus 2. So put this in equation 2 to get the final equation. Put this in equation 2. That is I is equal to 2 minus 2 into e raised to minus 2t. So this is what the transient response. This is what my total response for current. Okay, so this is the answer of my first question. Determine I here. So further questions are there. They are asking, what are the questions? Voltage across inductor and voltage across resistor. So how to find out voltage across resistor? You can tell now. What is the formula? करंट I दिलाय ना, मग रेजिस्टर मधून कुठला करंट फ्लो होतो? यस, व्होल्टेज अक्रॉस रेजिस्टर काय फॉर्म्युला आहे? ओम्स लॉ.
I into R.
Yes, I into R. So VR is equal to R into I किंवा I into R. R व्हॅल्यू किती आहे? 30 आहे ना, 30 into this current. So current value is what? 2 minus 2 into e raised to minus 2t. जर तुम्ही 2 कॉमन काढला तर काय होईल? VR is equal to 30 into 2 means 2 we are taking common, 60 into 1 minus e raised to minus 2t. So this is what the answer of VR. So again the unit is what? Volt. Unit is volt. Now similarly, can we find out the voltage across inductor? Voltage across inductor, can we find? What is the formula of voltage across inductor? VL is equal to L into di by dt. So L is what? 15. So derivative of I term. So derivative of I means 2 minus 2 into e raised to minus 2t. As a derivation घ्यायचं तुम्हाला with respect to t. So can you solve this derivation and tell the answer? So VL is equal to 15. 2 common काढलं तर 2 काय होईल? बाहेर येईल. So what is the derivation of 1? That is the 0. Derivation of constant term with respect to t is 0. Next minus as it is. This derivation of e raised to minus 2t with respect to t is what? E raised to minus 2t
Into minus 2.
into minus 2. Okay. So 15 into 2 minus of minus this becomes plus, कारण इथं minus दोन्ही minus आहेत त्यामुळे plus होणार, आणि 2 परत आहे त्यामुळे VL is equal to 15 into 2 is 30, 30 into 2 is 60. Okay, 60 into e raised to minus 2t. So this is what the voltage, and unit is volt. This is what voltage across inductor. So once you get the current I, you can easily find out the voltage across resistor and voltage across inductor. So such type of simple questions they can ask for minimum 4 marks, maximum 6 marks. 4 ते 6 मार्कामध्ये ते क्वेश्चन्स विचारले जातात. And if you are referring the offline question papers, so the fixed question will be there based on RL or RC. RL किंवा RC मध्ये एक क्वेश्चन असतो, but values or structure may be different. प्रत्येक क्वेश्चन रिपीट होणार नाही. Okay, so this is what for today's lecture. So in the next lecture we can solve some more examples based on the RL circuit. Different variety of problems we can solve, which already asked in the university question paper, competitive examination like GATE. So such type of examples we can solve in the next lecture, and then afterwards we can start for DC response of RC circuit. If any questions will be there, you can ask, otherwise we can stop here. Okay. You can stop here.